Next page. There's a lot more in this problem. Take a moment and just read number 16, and I'll walk you through the whole thing. This entire problem is like the stuff that I did to you guys on the midterm exam review packet, where I tried to cram as much into one thing as possible. So there's a lot going on here. We'll be okay. There's two different particles. There's A and B. And first I'm talking about particle A. I want to know, are we moving left or right at time 1.5 and then speeding up or slowing down? Do you need any calculus work initially to figure out the left or right thing? What can you just do? Plug in. Go to your calculator. We are going to use the calculator for this. I want to find the velocity of particle A at time 1.5. By the way, it's calculus, so what does that tell you about your calculator? Radians. Not physics. Radians. Be in radian mode. And let's go find the velocity at time 1.3.
Mr. Richter, do you think degrees are like the decimals and radians are like fractions?
I think it's like inches and centimeters. They're just two different units.
But one is superior.
Right now, find the velocity at time 1.5.
All I'm saying is one seems arbitrary and one seems exactly.
Okay. So this is e to the 2 times 1.5 cosine 3 times 1.5. What is the velocity? Negative 4.234. Make sure you're giving things accurate to 3 places when we're using the calculator. So what? Moving left. I messed up a little bit on the directions. There should be something at the end that says justify your answer. So let's do that as well. We are moving left because v sub a at 1.5 is negative. Done. But I also want to know speeding up or slowing down. How do I do speeding up and slowing down? Okay, I'm going to get the acceleration. Then do I just care about acceleration? No, I need to look at both of them. Well, I already plugged into velocity, so that part's done. You need to take a moment, find your derivative of velocity, which to me looks like some product rule and chain rule stuff, and then plug things in there. See what you can do with this part. First times derivative of the second, which needs chain rule, plus second times derivative of the first, which again needs chain rule, I don't think you have to. You're just plugging into this anyhow. So I would just kind of leave it and plug in the 1.5. When you do this, though, please don't just tell me that the acceleration is positive or it's negative. Actually give me a number. That's kind of your proof that it is whatever sign you say it is. And make sure the numbers are accurate to 3 places. And after you're done and have found the acceleration, figure out your conclusion. Are we speeding up or slowing down? And justify that. Bless you. Do we have an acceleration? Yeah, 50.435. So what? Particle slowing down. And I'm going to say because the velocity of v sub a, not of t, I shouldn't say that, I should say of 1.5. You got to tell me you're referring to that specific instance. And a sub a of 1.5 have opposite signs. Questions on how that worked? Give you guys a moment. Good. Okay, so next, I want to, okay. The initial velocity of particle B is -1. Find the velocity at time 1.3. I need a velocity function. How do you get the velocity? Integrate. This is kind of like what we just did. Your velocity should be the integral of 4 over 12 minus 5t dt. You're going to integrate that thing, and when you're done, you're going to use this VB of 0 equals -1 to find your particular constant. Go do that. This, for right now, should be without a calculator. And of course, what's the trick we always use? Use substitution. No good. Use that, please. The c value, by the way, is not going to be super pretty. Whatever, that's fine. Just leave the natural log in there. Once you are done, then you're going to go to the calculator for find the velocity at time 1.3. Once you've figured out your c value and all that stuff. Did you get that kind of ugly negative 1 plus 4/5 ln 12 for your constant? I'm seeing nodding. Okay, that's encouraging. And I'm going to plug in 1.3. How about negative 0.376? Good. What's the particle's velocity at time 1.3? Negative 0.376. I'm going to wait a moment because I see a couple people still writing some things. Actually, when you're done, look at C and see if you can figure that out. When do the particles have the same velocity? So, yeah, the one that I gave you for particle A and the one you just calculated for particle B. Well, let's see. E to the 2t cosine 3t equals negative 4/5 ln absolute value of 12 minus 5t minus 1 plus 4/5 ln 12. How do you solve something really simple looking like that? Or not so simple looking? Calculator. It's up to you if you want to make it equal 0 and find where it crosses the x-axis, or just graph the two, find where they intersect. Oh, do you guys, by the way, know how to enter absolute values on the calculator? Ah, okay. What was that? You can, but it may create some other issues just by how the calculator deals with that stuff. Okay, so is this going to work? I bet if I turn this on and then open this, I can show you my calculator. Oh my gosh. Light's a good thing. Oh my goodness. Okay, so it's sort of showing up, whatever. I'm going to get my e to the 2t or 2x cosine 3x. Of course, we're still in radian mode. But then, to get absolute value bars, push math. Go over to number. It's the first option, ABS. I think on mine it's just going to leave it as ABS, but on yours it might actually give you the bars. Minus 1 plus 4/5 ln 12. Go graph, find where they intersect. I'm sure you'll have to mess with the window a little bit. But I think if you do this correctly, there should be two places where it happens. And of course, when you're done, how many decimals? 3. At least 3. If you don't trust your rounding, give it to more than 3. I'm getting only 2 places. Are you getting more? Okay, hold on. Oh, wait a minute. Go back to the original problem. I'm sure it says something there. Yep. Sorry, I missed that part. Time interval 0 to 2. Let's just set the window there. Yeah, of course, because of the trig thing, it's just going to keep doing that over and over. Set it 0 to 2. Sorry about that. Yeah, sorry. We're good. What? No, yeah, I remember there was a trick and oh my gosh. Some of you still going with the calculator. So what? What's the first one? 0.601, or if you don't trust yourself, 3 afterwards, whatever. How about the other one? 1.569 or 86 if you're not sure if you're going to round properly. Either of those work. Does this make sense? Any questions or issues here? Last part. What is the speed of particle A when particle B's acceleration is 0.8? How would I even start to approach something like this? Okay, let's figure out when B has an acceleration of 0.8. So I'm going to say, set the acceleration of particle B equal to 0.8. That gives me 4 over 12 minus 5t equals 0.8. I don't think this has to be a solved by graphing problem. I think you can use some algebra here. Cross multiply, solve that thing. And it'll be a nice enough time, like a terminating decimal. Maybe time 1.4. Now I want you to find the speed. What does that mean?
It means the
What?
velocity.
Not the average value of the velocity.
Absolute.
Okay, sorry, I heard average value. Yeah, speed is the absolute value of velocity. So I need to find the absolute value of the velocity at time 1.4. I think you should just plug 1.4 into your appropriate velocity function. And if you get a negative answer, change its sign. I wouldn't bother with the absolute value part of the calculator necessarily. Do remember, though, that we have 2 velocity formulas. Make sure you're using the right one. Problem? Or are you okay with that? Okay. Yep, I think it will end up being something negative. So make it positive to get speed rather than velocity. Speed is velocity without direction. How about like 8.062? Any particle motion questions? Let me turn this off.